Good day everyone. So for today's video, we'll tackle about the inverse of trigonometric functions. So what do I need to learn at the end of the lesson? The student should be able to recall on finding the inverse of basic functions and solve problems involving inverse of trigonometric function. Inverse of trigonometric function. Aristarchus of Samos, noted Greek astronomer who studied trigonometry. Claudius Ptolemy and Menelaus in Alexandria, Egypt. The Greek mathematical astronomers who developed further the study of early Greek astronomers in the first centuries of the Common Era. The ancient astronomers from 500 to 900 CE who decided to study what we now call the sine and cosine as functions of an angle in a right triangle. After this knowledge was brought to the Arab and Persian world in medieval times and developed further, it was transmitted to Europe through contacts among merchants and as a result of warfare. The word sinus arose from misinterpretation of the Arabic word for this concept. Thomas Flank of Flensburg, Germany, who introduced the names of tangent and secant into trigonometry in his book of 1583. Edmond Gunter, between 1624 and 1636, who invented cosine and cotangent with the prefix "cu" meaning complement. Daniel Bernoulli, early 1700, inverse trigonometric functions were considered and used ascend for the inverse sine of a number and in. Euler on 1736 wrote AT for the inverse tangent. G.L. Lagrange, as early as 1772, used the symbols arcsine and arctan. Euler and Lagrange were identifying an angle with the arc if it subtends when placed at the center of a circle. Jan Herschel introduced the inverse of sine and inverse of tan notations in the article in the Philosophical Transaction of London in 1813. So here are the following properties of inverse function. First is a function must be one-to-one in order to have an inverse function. Number 2, the graph of an inverse function is the reflection of the original function about the line y is equal to x. The third one is if x and y is a point on the graph of the original function, then y and x is a point on the graph of the inverse function. The last one is the domain and range of a function and its inverse are interchanged. Example, y is equal to cos x and in negative infinity is greater than x of greater than 8 ay greater than positive infinity. Not one-to-one sense, some horizontal lines intersect the graph many times. More than one x value is associated with a single value. The inverse relationship is not a function, it will not pass the vertical line test. As we can see the graph, a function must be one-to-one in order to have an inverse function. Y is equal to cosine x restricted cosine function is 1-to-1 and thus have an inverse function called our cos x or cosine inverse of cosine x.